Okay, 9.2 is finding the inverse of a function. It's kind of like doing the opposite. We mark it with this -1, meaning that instead of putting in x's and getting out y's, you're kind of doing the opposite. You're putting in the y values and getting x values out of it. So it basically switches their spots. When we do this, we actually switch the spots of f of x and x. And when we do that, we have f-1 of x. That's the whole reason we switch those two things, is to do the opposite. And then it's just trying to get everything undone, so you get f-1x alone. And you do that following PEMDAS backwards, so like anything adding and subtracting first. So let's try this example. So the first thing, I've already done this for you. This is our original function. And then here's the n and the f of n. They need to switch spots. Everything else stays in their spot. So like the 2, the 1, the +2 at the end. The only thing that switched was these two things. And notice I put this -1 on it because it's the inverse. So now it's just trying to get that alone. So the first thing I would do here is minus the 2 to both sides, because if you follow PEMDAS backwards, that +2, add and subtract. So we get, let's do this all in one color. So we get n minus 2 equals 2 over f-1n. Oops, there we go. Plus 1. And now, if f is in the denominator, we actually want to move it all to the other side by multiplying it. So if I do that to this side, they cancel out, and it moves to this side when you multiply. So doing the opposite of it being in the denominator. Opposite of dividing it is multiplying it. So we end up with these two things, f-1n plus 1. We have n minus 2 equals 2. That's all that's on the right side. And now, these are connected by timesing, so PEMDAS backwards. There's nothing added or subtracted outside the parentheses, but there is something to divide. This whole thing. So you end up, let me move it over here, more room here. We end up with f-1n plus 1 equals that 2 over n minus 2. And the last thing to check is if there's still anything to add and subtract right there. So we subtract the 1. And the 1 is not a fraction, so it just goes right on the end. So you have your fraction still, and then you minus the 1, and that is f-1 alone, so that's our inverse. So our original was up here. And our inverse is what we ended up with. And we mark that with that -1. Let's try one more example problem. So first thing you want to do is switch the spots of x and f of x. So this guy and this guy. And no other numbers move. It's just the x and f of x. Even exponents wouldn't move. So we get x equals 15 minus 6 with f of x. But now we're going to put that -1 on there because we switched it. We're marking it as the inverse, the opposite. So the first step here, if there's anything adding, subtracting, which the biggest thing is this fraction. So let's get rid of it. So we end up with 5x equals 15 minus 6 times f-1 of x. Now, a lot of people want to take this and add them together, but you can't do that because 6 is attached by multiplying. There's like this invisible parentheses keeping them together. So instead, next step, adding and subtracting, this 15 is already by itself, so we're going to subtract it to this side. So we get 5x minus 15 equals -6. f-1 of x, and again, if you notice here, this f-1 of x, when you have it with a number in front, they're connected by timesing. A lot of people want to add the 6, but they are, look how it's connected to the f. It's times. So we undo it by dividing. So we get 5x minus 15 over -6 equals f-1 of x. And that's your final answer, but formatting wise, we always want to move the negative up top. So it's negative 5x plus 15 over 6. And then the last step is we don't start with the negative. So if we can, move the positive first. So if you're looking at like tests, like multiple choice, you'll see this answer way more often, just formatted correctly. And that is inverses.